Number 19 on page 478, they're asking us to graph something that looks like this. Anytime we graph, we have to get our A, B, and C first, because that's going to help us find our axis of symmetry, negative b over 2a. A is negative 2, B is negative 3, C is 10. So x equals negative b over 2a. So x is going to equal negative 3 over 2 times negative 2. Negative 3 is 3. Negative 2 times 2 is negative 4. So negative 3, or 3 over negative 4. That's the same as negative 3 over 4. That's the same as, it doesn't matter where the negative is, top, bottom, or middle, as long as there's only one of them. So x equals negative 3 over 4. Then we just means we have to find our y after that. So we know this thing is going to have to go through right about here, negative 3 over 4, right between negative 1 and 0. So x equals negative 3 over 4. That's our axis of symmetry. Now we have to plug that in to get our vertex. This is going to be annoying because it's going to be fractions, but let's try it. So y is going to equal negative 2, and then I plug in negative 3/4, square it, minus 3, and then I plug in negative 3/4 for that second x there, plus 10. Again, we have to do the exponents before we do the multiply by negative 2. So negative 3/4 squared is 9 over 16. I have negative 2 there. Negative 3 times negative 3/4 is positive 9/4. You can think of this negative and this negative as canceling out and making it positive, plus 10. So now this is negative 18 over 16, because I multiplied 9 times negative 2, plus 9 over 4, plus 10. If I common denominate everything, I'm gonna put it over here. I get negative 18 over 16 plus 36 over 16 plus 160 over 16. So I add all these up, I get 18 plus 160, I get 178 over 16. That ends up being 11 1/4. So my y aspect of my vertex is going to be 11 1/4. So when I graph this, my vertex is going to be negative 3/4 from when we did negative b over 2a, and 11 1/4 from what we just found for y by plugging it in. So we get negative 3/4, 11 1/4. Look, it's going to be like, might be even up here. Let's do these by 2. So 2, 4, 6, 8, 10, 12. So it's going to be right in here. That's our vertex. Negative 3/4, 11 1/4. Now we just have to find a few more points. We want to choose points that are equidistant from negative 3 over 4. That might be hard to do, but let's try it. I'm just going to go up 1/4, or no, I'm going to go up 3/4 to 0, and then I can go 1 from there, and then I'm going to go down 3/4, so it's going to be negative 1.5, and then up here I'm going to go down another 1, so it's going to be negative 2.5. So I went up 3/4 to get to 0, I went down 3/4 to get to negative 1.5. I went up 1 to get to 1, I went down 1 to get to negative 2.5. So I know this is looking kind of messy, but I'll try to clear it up here. So if I plug in 1 up here, I get 1 squared times negative 2 is negative 2, and then it's going to be minus 3, because negative 3 times 1 is negative 3. So negative 2 plus negative 3 is negative 5 plus 10 is 5. So this is going to be 1 comma 5. I bet this one's going to be 5 too. Plug it in and see. But if you plug in negative 2.5, believe it or not, it's going to work out, and it's going to be 5 as well. For this one, if I plug in 0 for all these, it's just going to be 10 here. If I plug in negative 1.5, I'm going to get the same thing. It's going to equal 10. So I just have to graph these points now. So I already have negative 3/4, 11 1/4. Now I just graph 0 and 10. So again, these are in 2s, 2, 4, 6, 8, 10. And then I have negative 1 1/2, 10. So right there. And then I have 1, 5. And then I have negative 2.5, 5. So it's going to look like this. This is a pretty gnarly one because it's got fractions and everything. But as long as you get the vertex and then take a couple points from each side of it, you'll get a nice looking graph. 10 is the y-intercept. C is always the y-intercept. So we know this is going to cross y at 10, and that's substantiated by this point here, 0, 10. It means that when x is 0, y is 10. That's the definition of a y-intercept. Anytime x is 0, that's going to be when it's crossing the y-line. But you can always use the y-intercept to help you graph, because you know it's going to have to go through the y-intercept at 10. It may not be the vertex of the function, but it will have to go through the y-intercept at 10, at positive 10, which this one does.